Hey class, welcome to your first chapter, your first lecture of our Human Growth and Development class. Hopefully by now you've had some time to familiarize yourself with Moodle and checked out the rest of the things that are posted for this week. If you look under where this lecture is posted, you will also see that I have provided all of these PowerPoint slides for you there so that you can follow along and that you also have the information that is on the PowerPoint so that you can use that throughout the semester to reference back for quizzes and assignments and such. So really when we're talking about the science of human development, we're really looking at trying to understand how and why people everywhere of every age change and develop over time. And as we're going to talk about through this class, there's been a lot of different ways that the human growth and development has been studied throughout the years, and also changed in our perspective of what is possible as far as how humans continue to grow and develop throughout the lifespan. So instead of just thinking of growing and developing in childhood and early in life, instead looking at the whole lifespan perspective and taking into account that changes and development can happen all throughout the life stages. So when we're talking about how we study anything scientific, including human growth and development, we're going to be using the scientific method, which is really a way to answer questions using empirical research and data-based conclusions, so that these aren't just theories that are being flung around, but that they are tested and found to be true throughout using the scientific method. The essential steps of the scientific method really begin with the curiosity to pose a question. So why something happens the way that it happens, or why is it that human beings continue to develop throughout the lifespan? And then thinking about why that could be. So the next step would be to develop a hypothesis. This is a prediction that can be verified, right? So a hypothesis is the prediction of what the answer to that question will be, and then also needs to be able to be verified, because the next step is to then test this hypothesis. From testing the hypothesis using research and objective research, so not going into the experiment or the test with a certain outcome in mind, staying objective to what the research will show, drawing conclusions from that, and then reporting those results. An important part of this process is the ability to repeat a study, which is known as replication. This is sometimes considered to be the sixth step of the scientific method, since being able to replicate other researchers' work is incredibly important. As you can understand or imagine, if one researcher says that this is the outcome of the study and this is the truth as proven by this scientific method, if it can't be repeated, then it would indicate that perhaps there was some bias in the study and that conclusion cannot be trusted objectively. So replication is very important. So again, the science of human development really seeking to understand how and why people of all kinds, everywhere of every age, change over time. And as we're looking at how we are going to study this human growth and development, we are going to be looking at different areas of growth, including multi-directional, multi-contextual, multicultural, multidisciplinary, and plastic. And we will be going over those terms more as we progress through the chapter. So as we're looking at this question, the question of do you need friends, and looking at a scientific meta-analysis. A meta-analysis is something that combines results of many studies and avoids drawing any firm conclusions from any one study, because that one study might not have enough participants, or like I was talking about, some kind of unknown bias. So the meta-analysis is sort of what comes from the replication, being able to look at all of the different results and then come to the conclusion. So the meta-analysis on the effects of loneliness is that, yes, definitely we need friends and social support. Lack of social connections increased heart disease by 29% and stroke by 31%. So while having friends does not eliminate the risk of stroke or heart disease, it does appear to have an effect on your long-term health. The nature versus nurture controversy, I'm sure a lot of you are very familiar with this already. It's the question of, is somebody born a certain way, or do people develop and turn into who they are because of the way that they are raised and brought up? And nature is the genetic influence on a person, right? So the genes, the biology, and nurture is the non-genetic influences on each developing person, which is everything from the mother's nutrition while pregnant all the way out to the national culture. So nature always affects nurture, and then nurture affects nature, and that's the truth. Is it goes two ways. It's not one or the other. What we do know is that sensitivity to any particular experience differs from one person to another because of the particular genes each person has inherited, or what happened to that person years earlier. So an example of that would be adverse childhood experiences, ACEs. Childhood experiences have been proven to have harmful effects on development, and physical and emotional problems in adulthood can be traced to ACEs, to those adverse childhood experiences. Now, somebody who has adverse childhood experiences or scores high on that assessment are then going to have a harder time with things that somebody who has a lower score on that assessment, probably they wouldn't have such a hard time with. And again, the lifespan perspective, looking at the entire range of development, and again looking at development viewed through these different lenses that we are going to get into as our chapter goes on. And here you have a table that really kind of breaks down these different developmental stages and sort of the age at which we expect to see them occur. That doesn't mean that these are the only time that these things can occur, but these are the time periods that we will be looking at, and kind of how they're broken down into age groups. So age ranges for different developmental stages. Again, development can happen, right? It's a little bit fluctuating, but usually we're talking about infancy, 0 to 2 years, early childhood, 2 to 6, middle childhood, 6 to 11 years, adolescence, 11 to 18, emerging adulthood, 18 to 25 years, adulthood is 25 to 65, and late adulthood is 65 years and older. We will be covering all of these different developmental stages throughout our class. Okay, so the first thing that we are going to talk about is that development is multi-directional. So over time, human characteristics can change in every direction. So this is not the idea that everybody goes in a straight line from point A to point B in development, and that human characteristics are changeable in every direction. So couple different ways that things change: discontinuous versus continuous. Several major theorists describe stages of development as a discontinuous process, such as Freud, Erikson, and Piaget. Others view development as a continuous process. You'll see here this timing of losses and gains, and then this critical period and sensitive period. So a critical period is when scientists consider some changes sudden and profound because of this critical period, and that's really a time when something must occur for normal development, or the only time when an abnormality might arise. So an example of that would be the critical period for humans to grow arms and legs, hands and feet, fingers and toes is between 28 and 54 days after conception. That has to happen then. After day 54, that critical period is over. We do know that there are not many critical periods of human development, but there are sensitive periods. And sensitive periods are when a particular development occurs more easily, so not exclusively at a certain time. And a good example of that is language. If children do not communicate in their first language between ages 1 and 3, they might do so later, so it's not critical. If they don't start between ages 1 and 3, it's not over and they'll never speak, right? But their grammar is often impaired if they do not start during that sensitive time period. Here's a graph that just shows patterns of developmental growth. And as you can see, there's a lot of different ways that developmental growth can occur, with growth and decline, linear growth, and growth in multiple stages, as well as just unpredictable growth and change. So the next part of this that we're going to be discussing is that development is multi-contextual. So basically what this means is that human development does not happen in a vacuum, and that there are these ecological systems that have been identified that each person is affected by. So this includes social contexts and interpersonal interactions. And we really talk about 3 nested levels surrounding this ecological system. So this was Bronfenbrenner is who developed this, and this approach was later named the bioecological theory. And as you can see here, the ecological model, so the most obvious is the microsystem, which is each person's immediate social context, such as family and peer group. And then also important is the exosystem, which is local institutions such as school and houses of worship. And then beyond that is the macrosystem, which is the larger setting and includes cultural values, economic policies, and political processes. So in this kind of context of looking at multi-contextual development is historical context and this term cohort. So a cohort refers to people who are born within the same historical period, and they move through life together, experiencing the same events, technologies, and cultural shifts at the same ages. As our generations are labeled, right? Gen Z, Gen X, boomers, those kind of things. Those are different cohorts. And we, at that generation, we all are experiencing some of those same contextual events at the same time. And then that impacts the span of development. There's also a really important aspect here of socioeconomic context, and you'll see there's a video in this week's assignments that really discusses socioeconomic status. And socioeconomic status is a combination of a person's position in society that's determined by income, wealth, occupation, education, and place of residence. And socioeconomic status has been shown to have quite an impact on development and people of higher socioeconomic status who have, stable housing, stable family life, stable food security, all of those things, education, tend to have an easier time reaching those improved outcomes. Okay, so there's a little case study here for you to consider, and this is just sort of a little example of culture and how different cultures can be interpreted differently. So there are ethnic cultures, national cultures, family cultures, college cultures, and more, right? And we all belong to several groups, which can lead to a cultural crash. So when you think about this question of how would you react if a mother in your child's class slaps her child in the face for interrupting an adult conversation, how you perceive that, right? If you think the child was being rude, or on the contrary, that her mother should not have slapped her, I would vote in 2026 that maybe her mother should not have slapped her. However, there are, of course, lots of different cultural beliefs around the world, right? And in our own country that might impact that. And so your answer to that question and the response that it elicits really reflects your culture. A culture is a system of shared beliefs, norms, behaviors, and expectations that persist over time and guide behavior and assumptions. Each family, community, and college has a culture, and individuals within every culture sometimes rebel against their culture's expected beliefs, conventions, norms, and behaviors. And then you also have social construction, which is concept created or constructed by a society. Social constructions affect how people think and act and what they cherish, ignore, and punish. And one of the really important things to consider as we're talking about culture and different viewpoints is this difference equals deficit error. And that's really the belief that just because something is different than your own culture, that therefore it is wrong, or it needs to be changed, or it needs to adjust somehow, or that, different cultures should be feared or criticized. And that is really counterproductive to a multicultural perspective where, remembering that there are aspects of our own culture that other people would not agree with, and that does not mean that one is right and one is wrong. As we're talking about the multicultural, we also learn about the difference between an ethnic group and race. And an ethnic group is really a group of people whose ancestors were born in the same region and who often share a language, culture, and religion. Social, not biological construct. Okay, so this is not biology. This is, again, sort of when you think regional, right? Like regional language, culture, that sort of thing. Race is a group of people who are regarded by themselves or by others as distinct from other groups based on physical appearance. There are social scientists who think that race is misleading, as biological differences are not signified by outward appearance. So that's also something to keep in mind. When you look at this graph of intersectionality, intersectionality begins with the idea that everyone is pushed and pulled, sometimes strongly, sometimes weakly, sometimes by themselves, sometimes by others, by gender, religion, generation, nation, age, culture, ability, and ethnicity, and that our many different identities interact with and influence each other, changing over time. So as you can see, this graph does a good job of demonstrating how these different things can interact and overlap, right? When we're looking at this, it's important to remember that there is clear evidence in the data surrounding life expectancy that overlapping of too many marginalized group, so a combination of racism, sexism, ableism, ageism, and so on, may harm individuals. So if there's an individual who has multiple marginalized, is in multiple marginalized groups, right? Then the impact on their life expectancy can be shown in data. Okay, so development is also multidisciplinary, and that means that many academic disciplines are relevant. So biosocial includes biology, neuroscience, and medicine. Cognitive includes psychology, linguistics, and education. And psychosocial includes economics, sociology, and history. Economics is also relative to every physical and cognitive domain of lifespan development. And it should not be considered alone. When we're thinking about economics, we will take into account socioeconomic status, which again, I was describing earlier as that combination of all the different factors. So also, development is plastic. And what this means, this plasticity, denotes two complementary aspects of development. So both that people can change over time, and also that new behavior is affected by what has already happened. So people can be molded as plastic can be molded, yet people can also maintain a certain durability as plastic does. So this provides both hope and realism. Hope because change is possible, and realism because development builds on what has come before. So there is evidence in the dynamic systems approach, which is a framework that many contemporary developmentalists use, where the idea is that human development is an ongoing, ever-changing interaction between the individual and all the systems, domains, and culture. There's just another note about that dynamic systems approach. So it's sort of the idea that it urges considerations of all of the interrelated aspects, every social and cultural factor over days and years. So the idea that things are sort of building on top of each other. One of my favorite things about the study of human growth and development is the exploration and discovery of neuroplasticity. So what neuroplasticity indicates is that the expansion of neurological structures, emerging networks of communication between one cell and another, and creation of neurons, which are brain cells, occurs throughout life, even in late adulthood. So I feel like that is just such a really hopeful finding, and really miraculous that our brains are able to change and grow and create new ideas and pathways even into late adulthood. So back to some things about science, since you are in a psychology class and we are learning about human growth and development through science. So science is not a belief system. It is a very special way of learning about the true nature of the observable world. So it's not a debate. It's not an opinion. It's science. It's facts. It's looking at facts and how to learn and develop and again, test those hypotheses and come up with new ideas and test them out. Scientists use 3 basic research designs and 3 strategies to study change over the lifespan. So let's go ahead and look at those. So the first one is the survey. A survey is, the pros are, it's simple, it's the least expensive, it's informative, it's also less accurate. The challenges include getting representative sample, refusals for people to participate, which I am guilty of when I get asked to participate in a survey. Wording and survey construction, right? Not everybody understanding the questions and making sure, again, that it's taking into consideration different cultural contexts. And then also misreporting, as well as just the influence of the survey takers. So it's hard to get a big enough sample. And again, it's hard to make sure that the language of the survey is objective and not leading people to a certain answer. Then we have scientific observation, and this is really good because it's just unobtrusively watching, right? Just watching and recording. So the tendency towards bias would be pretty low as long as, it's just that. It's just observing and making notes. It's systematic and objective in a naturalistic setting in a laboratory or searches of archival data. And observation can also use data that reflect what people have already done. Okay, and then we have the experiment. And the experiment is aims to establish causality by imposing particular treatment on participant groups, noting treatment effect. Okay, so you have an independent variable. An independent variable is introduced to see what effect it has on the dependent variable. And the dependent variable may change as a result of whatever new condition or situation the experimenter adds. So you can think about the dependent variable is something that does not change, right? This is the thing that's just sort of the static group, the control group. It's something that it just is, right? And then you add something new in, and then observe the change of whatever new condition or situation, right? If there is a change, because obviously, again, in science, there is no guarantee. So that's where that objective nature comes into play. You have the experiments, much like the dependent independent variable, you have the control group and experimental group. So if you have a group of people, the experimental group is the group that will experience the particular treatment or condition, the independent variable, and the control group does not receive the experiential group treatment, okay? And then that way you have those two groups to compare so that you can clearly see if there was any change when the experimental group had the treatment or condition added in. So here would be a good little graph on how to conduct an experiment, and that kind of gives you a nice example. Again, these slides are all available for you to look at under this lecture, so you can spend more time looking at that breakdown of the experiment. So when we're thinking about developmental science, we have to also remember that developmentalists need to measure how people change or remain the same over time. And in order to do that, scientists design cross-sectional, longitudinal, or cross-sequential studies. Cross-sectional research is comparing groups of people of one age with people of another age. And people being compared may not be similar in every way except age. Longitudinal research is collecting data repeatedly on the same individuals as they age so that you can track the changes. And then that also shows when in the lifespan to focus on better health practices, education, and family interactions. And then cross-sequential research is really studying several groups of people of different ages, so a cross-sectional approach, and then combining that with the longitudinal approach, because then following them over years. This is the most time-consuming and complex, as you can imagine, combining both of those types of research, but it does yield the best information, which you can also understand because you're getting a really great sampling, and then you're also being able to follow that sample over a time span of years. So cross-sequential research is the most time-consuming and complex. It does yield the best information. Hundreds of scientists research the same topics, replicating one another's work to gain some advantages of cohort sequential research without waiting for decades. So again, that replication comes into play and can be such a beneficial tool. So contrasting perspectives of science and truth. Many non-scientists are critical of science, and really what needs to be addressed, I think, is that if scientists and non-scientists really come at each other with an air of arrogance and, I'm right and you're wrong, and anger and disdain, no one is going to consider anybody else's views. And then nobody will grow and learn and change, right? Which is always the hope when we're thinking of how to continue on and become, wiser and to understand more, is to be able to speak to each other about things that are different, or even things that we don't understand, to be able to ask questions instead of coming in with an attitude of, I'm right and you're wrong. There are two attacking sides, are often science and religion. And again, just a note here about when people on either side stop listening to each other. And also remembering that science is not, it's not an opinion, it's not a story. There are steps that are taken in science to validate or invalidate a hypothesis, and it just is that simple when it's done correctly. There's no bias, there's no hope of swaying one way or another. It's just to figure out the answer to a question. And so really something for you all to think about. Can science and religion, non-scientists and science, is there a way that people can use these things to be more complementary and not so conflicted? So as we're talking about science too, and sometimes as it's misinterpreted, we're going to talk a little bit about correlation and causation, because they're two different things. Correlation happens between two variables if one variable is more or less likely to occur when the other one does. So a positive correlation, both things tend to increase or decrease together. Negative correlation, one increases and one decreases. And then zero correlation means no connection. I just really want to stress here that just because there's a connection to something, because there appears to be a correlation, that does not mean that one thing caused the other thing. And I think that does happen a lot in science, when science is interpreted and misinterpreted. Correlation is not causation. So here's a little questionnaire to think about for correlation. So what do you think, these two variables, ice cream sales and murder rate, positive, negative, or zero correlation? And then why? Why would there be? And this might surprise you, but there is a positive correlation between ice cream sales and murder rate. And the third variable, the why, is because of the heat. Reading ability and number of teeth, that has a negative correlation. And the reason is because of age. Because as a person is older and they have more teeth, they have improved reading. And then the third is adults' sex assigned at birth and average number of offspring. There is zero correlation because each child must have a parent of each sex, and there is no third variable. Okay, so quantity and quality. So quantitative research provides data that can be expressed with numbers, such as ranks or scales. It can be easily summarized, compared, charted, and replicated. And it provides numbers that may overshadow nuances and individuality. Qualitative research considers qualities instead of quantities, asks open-ended questions, and reports answers in narrative, non-numerical form, and can provide descriptions of particular conditions and participants' expressed ideas. So These days, some studies are using both of these measures, and that can provide richer and more verifiable details. Note about ethics. Each academic discipline and professional society, like I'm a licensed professional counselor, so I have a specific code of ethics that I have to follow, which is not a set of laws, okay? Ethics, it's a moral code, a set of moral principles, right, that I follow as a counselor. The same thing is true for scientists and a professional society that's involved in the study of human development. Another note is an institutional review board, IRB. This ensures that research follows established guidelines and remains ethical. Historically, these things have come to be, not out of nowhere, but because historically there have been studies that have been done for sure in the scientific field that would now be considered pretty unethical. And if you've taken general psychology, we definitely went into some of those. But in order for a scientific study to move forward, participation has to be voluntary, confidential, and harmless. And research subjects must be given informed consent, that they understand the research procedures and any risks involved before that can carry forward. Here's just a note about, some dilemmas that arose over the COVID-19 pandemic, and just some, good pondering to think about some larger ethical dilemmas and questions related to culture, and, the implementation of all of the regulations and everything that happened, and that did really shift things in the broader world and definitely in our culture. So I think that's a thing that we have all lived through that we can reflect on as something that did shift a lot, and shifted development, certainly, especially for kids who had such disruption in their education. Again, just another, note about ethics. Researchers need to follow ethical standards to reach conclusions. When conclusions are not what they or their culture, developmental science needs to address issues that will help everyone. And the next cohort of developmental scientists may study issues that prior scientists avoided, raising questions that no one has asked before. And that concludes our lecture number 1. So I hope you learned something from that and from reading your first chapter. And I hope the first week of school feels exciting, and we're going to learn a lot together over the semester. So please reach out to me if you have any questions or concerns. My phone number is listed in your syllabus. The best way to get a hold of me is through text message. All right, you all, take care, and I hope you have a really great first week of school.